So hello everyone, hope you're doing good and welcome back to my channel. Today we are at day 11 of the June daily Leetcode challenge and we have a medium level question in front of us. So the question says that, it's question 1146 snapshot array. Okay. So it states that we have to implement a class in which there are going to be four functions. We will have to implement each of these. Okay. We will see the definitions of each of the functions and then let us understand what the actual demand of the question is. Okay. So implement a snapshot array that supports the following interface. Okay, the first one is the constructor for it. Okay, what happens is initialize an array like data structure with given length. Initially each element is zero. Okay, so what it means is, see, let me tell you this. So the length is going to have this range. Okay, it's almost the biggest range possible, near to 10 power 5. Okay, so what will happen is, see, snapshot array means it's basically array. Okay, it will have first they will be provided with the length of it. Okay, the length will, for example, 10 power 5. So there are going to be 10 power 5 places, or placeholders for the arrays, and initially all of them will be zero. Okay, in the coming functions, that is the other three functions, we will be manipulating with those values. Okay, so the first function is a constructor function. It just initializes the array like data structure, okay, for the given length, and all the values for that, all those lengths are initially zero. Okay, next comes the set function. Okay, set function will tell me the index and its value. Okay, so what it means is, sets the element at the given index to be equal to the value. For that, for example, if I pass zero index and if I pass a value 5, so what it will be done is, the zeroth index will be made to have a value of val. Okay, that means zeroth index will be modified to 5. That is the basic idea, friends. Okay, now comes, see, these two functions are very simple functions. Okay, there is nothing more in them. But now comes the actual thing. What? Okay, that's the snap function. What snap means? Takes a snapshot of the array and returns the snap id. Okay, the total number of times we have called snap minus 1. Okay, the total number of times we have called snap minus 1. What that means is, for the first one it will be 0, for the second snap it will be 1, and so on. Okay, it will start with 0. That is the basic idea. So total number of times we have called snap function minus 1. Okay, takes a snapshot of the array. Okay, and returns snap id. Okay, snapshot means, see, snapshot, if you are not aware, so, okay, in industries we actually use these terms. Snapshot means saving array, okay, forever. Now no changes can be made to that array. Okay, that is what is the idea of snapshot. Okay, as you will see in the fourth function, we'll be using that snapshot. Okay, for now just understand that snap means saving that array and no further changes can be made to that array. Okay, now comes the fourth function, that is again an important one, get function. What happens is, we are given a snap id and an index. Okay, what we have to do is, returns the value at the given index at the time we took the snapshot. So, as I told you, snapshot means we have saved the array, no more changes can be made. Okay, that snapshot has a number. For example, snap underscore id will show that number. Okay, so if I say in the snapshot number 2, go to index 5 and get me the value, here I have to return that value in the get function. That is the basic idea. So I think you would have now understood what is this whole problem about. Here we are capturing a snapshot of the array. Okay, this function initializes the array. This function sets the value of the array for a given, let us say, for a given time. After the once this snapshot value is called, that array is wrapped up and we cannot make any changes to that. Okay, so that is the basic idea. And with this function, we go to the past snapshots and get a value for a particular index. So here, friend, that is the basic idea. The most simple implementation, let's see, actually, say, what will be optimized one depends on these values. Okay, what is given here. But if you see, the length is going to be 10 5 into 10 power 4. Okay, so when I see this value, see, no, usually when if I see such a question, the first thing that comes to my mind is, a 2D array. Why a 2D array? See, the first row can be a snapshot 0, a second row can be a snapshot 1, and so on. Okay, so we can have a 2D kind of, you know 2D array, or list, whichever we call it. So we can have that, and each row will represent a snapshot. Okay, but each row length will be this much. Okay, each row length will be this much. Remember that. But if you might be knowing, as you might be guessing it correctly, this approach is going to be, a lot. It will lead to a lot of wastage of space. Okay, this much space we cannot, afford to waste. So it's not an optimized solution. Now coming to the second approach. What is the second approach? In the second approach, we will not be saving the whole array, but instead we'll be saving the individual elements for each changes. Okay, and that is what is going we are going to do here. Okay, and in this question we will learn about important function called the bisect function and how it works. So I would design a sample demo for you. You will understand how it works exactly, and in this particular scenario, in this particular question scenario, how it will be useful. Okay, so we'll see that now. So coming to the code, and this is, as I told you, this is a constructor function. Okay, in Python it is called the init function. Okay, so here we're declaring the parameters which we are going to use. Okay, so I will have only two parameters. One is the ID parameter and the other one is the history records parameter. Okay, see, the ID parameter will tell me what is the current ID for which we are going. See, for example, see, once we declare close a snapshot, we have to close it. Okay, till then changes can be made to it. Okay, so this will tell me what are the changes going to be recorded for. It will be initially for the zero snapshot. Okay, next will be, see, this is a 2D array. Please make it, see, basically it is 3D array. Okay, it's a 3D array, but see here carefully, this is going to be a 2D array. Okay, what will happen is, see, for each index, okay, for each index I am going to maintain these values. For each, for example, it has 5 into 10 power 4 length. Okay, so for each of those, for each unit of that length, I am going to have a 2D array. That is the basic idea. For each index, that such array will be present. Okay, so, and these are just the enclosing ones. Okay, that is the basic idea. Here, as you can see, for underscore in the range of length. Okay, we will get more clarity on this when we go further. Okay, just for now, just hold your doubts. We will be getting the clarity once we go further. Okay, next comes the set path. Okay, here it's very simple. History records. Okay, as you can see, I will be going to the index that is they have given. Just go to the index. Once we go to the index, okay, once we go to the index, we will be having a 2D array like this. Okay, a 2D array like this. Okay, in that we'll be appending another simple array. Okay, remember, see, for each index it will look something like this. Okay, the highlighted part, for each index it is a 2D array. Okay, 2D array means you can just see it will be a list containing value like this. For each index it will be a list containing a single value like this. What we will do is, whenever a change is made, I am going to that index. Okay, I am going to that particular index and I am going to append to that list. What I am going to append, I am going to append this server id comma value. Okay, so what is, see, the disadvantage with the 2D approach was that, see, after each snapshot I have to save the whole array. But now what I am doing, I am only saving the value which has changed. Remember, till now the snapshot is not closed, so we are just saving those values which are changed, as and when they are changed, right? This is what we are doing. Next comes the snap function. Here I am updating the snap, that is server.add plus server ID plus equal to 1. That is, I am updating the snapshot by 1. I am returning the old snapshot value. Okay. Once this is done, next all set functions will have the new ID. Remember that. That means old ID cannot be changed now. See, old ID, whatever we saved, it cannot be changed now. It cannot be updated now. Okay, that is saved forever. Okay, that is the basic idea. Now comes the most trickiest part. Okay, what we are doing here is like very confusing for beginners, but as I told, I have designed a scenario for you, and this scenario will help you understand what we are doing. Okay, so before explaining the get function, I will explain you the scenario first. Okay, for example, see, I am having array. Okay, it has values 5 comma 1, 5 comma 2, 5 comma 3, 6 comma 1, 6 comma 2, and 6 comma 3. Okay, what I will do is, bisect function in Python, we are going to see, whenever we want to do a binary search, binary search using the functions, we will use the bisect function. Please make this point very clear. Okay, it's used for binary search in Python. Okay, now comes the bisect underscore right function. What it means? It means that it will tell me the right location to add this particular value. Okay, and if values are, for example, if already value exists for this, for example, bisect underscore add means, see, the idea here is, suppose I'm going to insert a value 5 in an array, and suppose that 5 already exists. So what it will do is, it will tell me the rightmost location where it can be safely added such that the array remains sorted. Okay, that is the basic idea of basket underscore right. Right here means it will give me the rightmost location of addition where I can add the particular number such that the sorted order of the array is maintained. Okay, so in this case I'm going to add 5 comma 99. 99 is going to be, let us assume, it's the biggest integer possible. Just assume for now. Okay, it is the biggest integer possible. Okay, if you run this method, you are getting the answer is 3. Why you are getting the answer is 3? Just see, let us see. It's index 0, index 1, index 2, and after that it will be inserted. That is what this function is trying to say. After that this will be inserted, correct, right? 5 comma 99, it will come after 5 comma 3 and before 6 comma 1. Okay, that is the basic idea, friends. That's what we are going to do here. Okay, so what I have to do is, for the given snapshot ID, I have written this index. Okay, I'm, see, for see, once I go to this index, all the values stored will be for a particular snapshot ID and its value. Okay, a snapshot ID and its value. Remember one thing: for a given snapshot ID, there can be multiple values also. There need not be only one value. Okay, because see, this function is being called every time we are doing a set. Okay, but uh, snapshot will be finalized only once. Okay, that means for every ID there can be more than one values. That every snapshot ID there can be more than one values for a given index. Okay, please make this point very clear. Ultimately, we have to take the rightmost. That's why we are going to use the bisect underscore right function. Ultimately, we have to take the rightmost. Okay, so what are the things which are finalized for us? See, index is going to be finalized because see, they will be giving us the index. Okay, index is finalized. They will be giving us the snapshot ID. That is, this is also finalized. Okay, this is also finalized for us. Okay, only thing which we don't know is that is the value. What is the value going to be? Okay, what is the value going to be? We want the rightmost value. So what we should do? We are going to take this value. Okay, see, they have clearly mentioned the value, how the highest possible value is going to be 10 power 9. That is what we have given here. Because see, I want the index of the latest value for this particular index and for this particular snapshot ID. Okay. So what I'm doing, I'm going to use bisect.add function. Okay. I am going to pass this particular array. Okay. See, this array is this one. Okay. For this particular index. Okay. This particular index is being passed. In this array, I'm going to search the rightmost place to insert a insert these values. What it means, for this particular snapshot ID, I'm going to insert this value. It will give me the index for it. Okay, I will get that index and I will do -1 to get the more latest value. Okay, the latest value for this particular index for this particular snapshot. Please make see, if you understand this example, the fourth function, that is the get function, is going to be really easy for you. Okay, it's going to be really easy for you. See, here passing see, this function basically returns the best place to add a particular value, such that the sorted order is not harmed. That is the basic idea. So I am saying I'm going to insert the biggest value for this particular snapshot ID and for this particular list. Okay, so it will give me the rightmost place. I know that place, something else will be there, but we do not want that place. We want that place -1. We want, see, this is the snapshot index. We want that place -1 because that will give me the latest value for this particular snapshot ID and for this particular index. Please understand this thing very carefully and remember, once I go there, I'm taking the first value. What is the first value indicate? See here, this has two values, right? This is the zeroth value, this is the first value. So we are taking only the first value. That means we're taking only the val. Okay, that is the only val we are taking. We don't want this self ID now because we are already providing that. Okay, that was the idea, friends. See, I've so many people approach me regarding what is the meaning of this. You will understand this only if you do the self experimentation with what is this bisect function and how it works. Okay, I've already given you a demo here. See, if we have 5,99, it will maintain the order. Okay, 5's order will be maintained. It will insert it before 6. That means this is the place. Okay, this is the place where it will insert it. It will pass me the next of that. But I don't want it. I want the latest. See, if I want the latest number, that is number 3 for this particular ID, what should I do? I will just call bisect underscore right. Okay, it will give me this particular index, that is the index after 5,3, and then do a -1. Okay, if you do a 3 -1, what you will get? 0, 1, and 2. So this you will get. Okay, this is what we wanted. This is the latest index. Sorry, this is the latest value for this particular ID. That is ID number 5. Okay, the latest value is 3. Okay, remember whichever value is updated, is at the right, it should be the latest. That's what we are doing. We are appending, right? So if I want 5,3, this is how I am doing it. I am taking 5,99 and then I'm doing. I'm assuming 99 is the highest possible integer value. Okay, for this example. So here the highest possible integer value is going to be 10 power 9, and that is what we are taking here. Okay, and finally, for see this ID we are getting now, sorry, this index we are getting, I'm going to do this index -1. See, this thing is same here. Okay, this thing is same here. Okay, and then I'm going to do a snap ID, sorry, snap index -1, and I'm going to do the first value out of that. That is this value. Okay, val, and that we are going to return. Okay, so yeah, that was the idea, and that was all about it. So idea here is, see, instead of storing a whole array for every snapshot, what we are doing is we are just saving the values, and to find the value for a given snapshot ID, we are using the binary search. So just think of it in this way. If you have saved the whole array for each snapshot, it would have increased the space complexity. But currently, what we're doing, we are only storing a single value for each, value change and for each snapshot. So it will definitely reduce the time complexity. If you talk about time complexity, see here, uh, this can be O of n because n depends on we are getting array. Okay, this is O of 1 because we are not doing anything here. Similarly, this is also O of 1. Okay, and this function will be having the time complexity of a binary search, which is going to be log n. So you can see here how much we are saving. Okay, But same thing, if you see, maybe like this get function, if you have implemented 2D array, it can be obviously O of 1, but remember how much space compulsory it will be. So that is the basic idea. Here we are trying to save the most, okay, the most possible, because for each ID, for each ID, when we are changing the, whenever we're considering a snapshot, we are not changing the, whole, saving the whole array. That is the only best optimization which we can talk about, okay. So yeah, that was all for today. I will definitely not say it's an easy question. To get this idea, it requires a lot. And so when if such a question comes in the interview, definitely the interviewer will give you some hints. Okay, he will try to bring you to this particular approach, and then you will have to code it. So please open your minds whenever you're doing a technical interview. See, many questions will come where you never get to know the solution. Okay, correct solution on first attempt, but you will have to get guided by those interviewers, and then you have to go the correct solution. Okay, that was the basic idea. Definitely, that was all for today. I know it's a long video. If you have any doubts, please do comment below. And before posting it out, my only suggestion to you will be, only advice you will be, please understand this part first. If you understand this part is nothing. Okay, this part is nothing. I have really done my best to explain you this. Okay, so yeah, that's all for today. See you tomorrow. Thanks a lot.